Hey class, Mr. Husted here, talking to you today about Chapter 1, Lesson 5. We're going to talk about pairs of angles and what kind of relationship they may have. So the first type of relationship that you probably already know about are complementary angles and supplementary angles. Okay? Complementary, hopefully you understand, they need to equal 90 degrees. Whereas supplementary angles equal 180 degrees. And generally these are pairs of angles that add together to make that 90 degrees. Now, what they mean here by adjacent and non-adjacent, adjacent means they share the same vertex. Non-adjacent means they don't. So they may be separated or somewhere else. Okay? So let's take a look at complementary and supplementary angles. So in the figure, name a pair of complementary angles, and name a pair of supplementary angles, and also name a pair of adjacent angles. So we'll color code this one. For our complementary angles, we need two angles that add up to 90 degrees. So if I'm looking here, I see I got 32 and I have 58. You add those two together, I know that I get 90 degrees. So I need this angle and I need this angle. So my complementary angles would be angle BAC. Again, remember, make sure the vertex is always in the middle. And angle RST. Again, remember, as long as your vertex is in the middle, you could flip-flop the other two letters, but make sure that that vertex is in the middle. So that's our complementary angles. Now, let's take a look at supplementary angles. And remember, supplementary angles add up to 180 degrees. Okay? So let's see. I need something that's going to end in a 0. So I'm going to look at 122 and 58. The 8 there would be 130. 50 plus 130 is 180. So these are the two angles I need for supplementary. So again, angle DAC and angle RST. Alright, so again, really stressing, make sure they are in, your vertex is in the middle, remembering that these add to 180 degrees, whereas this group added to 90 degrees. Alright, and then last but not least, we want to talk about adjacent angles. Adjacent just simply means they share a common side. So when we talk about sharing a common side, the only one that really works here is this one with this one. So they share that side AC. So for adjacent angles, we'd say something like angle DAC and angle BAC. Those are our adjacent angles. They share that common side. All right. So let's do a little bit more. Let's talk about complementary and supplementary without any pictures. So in example 2, letter A, it says given that angle 1 is a complement of angle 2, complement again just means that we're talking about 90 degrees here. We know that one angle measure is 68. How can we find the measure of angle 2? So just a quick little math lesson here. Measure of angle 1 plus the measure of angle 2 equals 90. That's complement. We know the measure of angle 1 to be 68. We don't know the measure of angle 2, but we know together they have to equal 90. This is like our variable. So to figure that out, we're going to subtract 68 on both sides. And when I do that, I get the measure of angle 2 equal to 22 degrees. Okay, so basically it's kind of like what we've been doing with the segment addition and the angle addition, is when we're missing, when we have the entire thing, in this case 90, and we have part of it, we subtract to find the other part. So now we're going to do the same thing, except now we're talking about the supplement. And again, supplementary means 180 degrees. So I'm just going to say 56 plus the measure of angle 3 is equal to 180 degrees. Subtract 56 on both sides. We get the measure of angle 3 equal to 124 degrees. So just some simple subtraction to figure out the complement or the supplement. Okay. All right, so example 3. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles, keyword there, with the ground. Find the measure of angle BCE and ECD with that picture. So what do we know about supplementary? Again, hopefully we're remembering that supplementary means that they add to equal 180 degrees. So again, we're going to start throwing in those pesky variables, but that just means we're going to add those together. So 4x plus 8 plus x plus 2 equals 180. Make sure we combine our like terms. So this would be 5x. Combine our constants, plus 10 equals 180. Subtracting 10 on both sides, 5x equals 170. And then dividing by 5, x will equal 34. So x in this case is 34, but we're not asking for x. We want the measure of this angle and the measure of this angle. So all we do is we're going to take each of those and we're going to put 34 in where x is. So in this case, 4 times 34 is 120 plus another 16, 136 plus 8. So that's going to equal 144 degrees. So this one is 144 degrees. We'll do the same thing with x plus 2. That's 34 plus 2, and that'll be 36. One way of checking to make sure is if I take 144 plus 36, if I add those together, I should get 180, and I do. So that's how I know I did the math correctly. Okay? So nothing different than what we've done before, just adding it into angles now at this point. All right, flip back side. Linear pair. So what is a linear pair? A linear pair pretty much are two angles that form a straight line. So if we look at this here, we see that we have a straight line here. Basically, if they are on the same line and they equal 180 degrees together, or if they're supplementary, then we have a linear pair. And now when we have two lines that intersect, we create vertical angles, and it sounds just like the name. So like angle 4 and angle 5 are vertical, and then we'd also say that angle 3 and angle 6 are vertical. Okay, so think angles across from each other. Those are vertical angles. All right, so we would identify all of the linear pairs and any and all vertical angles that we might have here. So I am going to start with, let's see, linear pair. So linear pair, need a marker. A linear pair. See, I see two here. So angle 1 and angle 4 form a linear pair because that's a straight line. And the only other one I see is angle 4 and angle 5. So those are our linear pairs. Now vertical angles are angles across from each other, which in this case, the only one that we have that is a vertical angle, let me change colors here, would be angle 1 and angle 5. Oops, need to throw that angle mark in there. Angle 1 and angle 5, because you have this intersecting line and this intersecting line. Angle 4 would be a linear pair with angles 2 and 3 together. Okay, but usually we don't count those because it's a pair. Pair means 2. If we have more than 2, then it's not a linear pair, so we aren't going to count that one. Okay, so just angles 1 and 5. Remember, linear pair across from each other. Vertical angles across from each other. Linear pair next to each other, and they form a straight line. Okay, all right, last one. Two angles form a linear pair. Find the measure of each angle. So again, a linear pair makes a straight line, or another way of thinking it is it equals 180 degrees. So I can take this angle plus its other angle, set it equal to 180, and then I can solve. I'll combine my like terms to get 6x equals 180. Divide by 6. X in this case equals 30. Again, we're not done there. They want to know the measure of each angle. So I'm going to take 5x and I'm going to plug 30 in, which will equal 150 degrees. And I'm going to take x and plug 30 in, which will give me 30 degrees. And then if I add them together, I would get 180, which means they are a linear pair. All right, so hopefully you learned a little something about angles and the relationships that they can form. Make sure you go over this again if you need to. If you have any questions, bring them with you to class, and we'll see you then.